Hello, in this video we'll solve the third question of our first internal test document. So the question we are given is construct a phrase structure grammar that generates all the signed decimal numbers consisting of a sign either plus or minus at the start and a non-negative integer and a decimal fraction that is either the empty string or a decimal point followed by a positive integer where initial 0 is an integer are allowed. Okay, so we have to create a grammar to represent as generate strings which it contains plus or minus sign at the start and a non-negative integer, and it also contains decimal numbers with which contains points, or it may not, it may also not contain any decimal number. Directly integers are also allowed. So I have created a grammar here. So S is the start symbol. You can, as we required sign at start, so we can replace S with sign and integer. As we are given, we have to use sign either plus or minus at the start, and we can have a non-negative integer. So I have first we can replace the start symbol with a sign and integer. Then as we can also have a decimal fraction that is decimal numbers. So another we can replace a start symbol with sign integer and dot, which will represent our decimal point, and a positive integer, as we do not have any negative integer or 0 after the point. Then sign can, as we are given that sign can be positive or negative, so sign can be positive or sign can be replaced with negative. Then our integer non-terminal will be replaced, can be replaced directly with a digit, or we can have multiple digits. So we can replace integer with a recursive call by calling integer with integer and digits. Then digit non-terminal can be replaced by 1 2 3 4 5 6 7 8 9 0 with any digit. Then if it is a decimal number we have to represent, then we have to use a positive integer after the dot decimal point. So positive integer can be replaced with integer or a non-zero digit. It can also be directly replaced with non-zero digit, or non-zero digit can be before the integer, can also be present before the integer, and positive integer can be also replaced with integer, non-zero digit, and integer again. This will provide us a recursion call, so we can have multiple number after the dot decimal dot. And non-zero digit can be replaced with 1 2 3 4 5 6 7 8 9 again digit, which and it does not contain any negative or 0. So I have taken an example here, that is minus 109, which is an integer, minus 109. So first, by using the rule first, I have replaced sign in integer, which is our start symbol, with sign and integer. And as we are representing minus 109, so minus we have replaced sign with minus by applying rule 4. Then by applying rule 6, I have replaced integer with integer digit, as I want more than one digits. So integer is replaced with integer digit, and again the same rule is applied, and integer is replaced with integer digit, and again then after integer is directly replaced to digit, and digit is then terminated with 1, and this digit is replaced with 0, and this digit is replaced with 9 by applying the rule 7. Okay, similarly, if we want to represent a signed decimal integer, that we can take example as minus 31.4. We can replace signed decimal integer with sign integer and a dot, then positive integer by applying the rule 2. Then we replace sign with negative as we required minus 31.4. Then integer with integer digit, and integer with then digit, and digit is then replaced with 3. This digit is then replaced with 1, and after the dot we only required one digit, that is 4. Therefore we directly replace positive integer with a non-zero digit, and replace the non-zero digit with 4. If we have required more than one digit after the point, we have replaced positive integer with a positive integer, integer, 0 digit integer. So we get a recursive call and we have more than one value, one integers after the point. One. The second question we were given is to give the Backus-Naur form of this grammar. So Backus-Naur form is nothing, it is just a notation technique to represent a context-free grammar, and you can specify it usually specifies the syntax of a language used to spell, and in this we represent it in the form of first symbols. On the left hand side we contain symbols which are non-terminal, then a double colon equals to sign, and then at the right side we have our sign we can replace with what we can replace with these non-terminals. Like in this example, I have replaced sign with plus or minus. If we have multiple, we can say multiple replacement, or we can replace it with multiple items, symbols, multiple symbols, then we separate them by using this OR operator. So we have to convert the before given string, before given grammar, into Backus-Naur form. So we can replace this two signs by applying OR here, and this is also can be replaced, can be written in only one line by applying a OR operator in between. Integer is also can be applied, and positive integers can also be done using the same thing. So I have changed it into Backus-Naur form by assigning OR operator in between, as you can see. This is the references I have used. Thank you.